Okay, try the warm up here on page 7. Pause the video until you have your answers. So this matrix, which we're adding, let's check the dimensions to be sure that we can actually add them. This matrix is 3 rows by 2 columns. And this matrix is 3 rows by 2 columns, and they need to be identical. So yes, we can add these together. And so we will get a matrix with the dimensions of 3 rows, 2 columns. So we're going to add the entries in corresponding locations. So 3 plus 0 in this spot. 6 plus -1 gets me the first row, second column. So second row, first column. Second row, second column. And so on for the first matrix. Now we've got subtraction. So this is 2 rows, 3 columns. This is also 2 rows, 3 columns. So my answer will be 2 rows, 3 columns. And now we're going to subtract -5 minus 6, 2 minus -5, -2 minus -6, 4 minus 1, -2 minus 3, and 0 minus -3. And there is the matrix, the result. All right, so now on page 8, what we're going to learn about today is scalar multiplication. This is different than regular multiplication, which we will do in our next lesson. Scalar multiplication is like a dilation. It's a coefficient. So when you have this 5 times matrix C, that means take each element in matrix C and multiply by 5. So 1 times 5, 2 times 5, 3 times 5, 4 times 5, and so on. And here is our matrix 5C with that scalar of 5. Okay, so let's find 9A. This unit, you have your calculator. So if you would like to do 12 times 9, you can do that. You don't have to show your multiplication. 5 times 9, -7 times 9, and then 18 times 9. Okay, so we're going to leave problem 3. You can use this for quiz review, extra practice. And then problem 4, we have 3A minus 2B. So what that wants us to do is do matrix A with a scalar of 3, matrix B with a scalar of 2, and then subtract. Again, use this one for quiz review. When the answers are in Drive, I will post the answers for those 2 questions. Okay, so now on page 9, I have a scalar of 3 and a matrix. So I'm going to do this scalar multiplication. 3 times 2 times u is 6u. 3 times v squared. Oops. Need a little bit more space here. 3 times v squared. And then 3 times u. That matrix is equal to 12, 9, and 6. The question says solve for u and v. With these matrices being equal, 6u equals 12. So we can write a little equation. So u is 2. Would that work for the bottom row? 3 times 2 is 6. That's good. All right, so now here we've got 3v squared equals 9. V squared equals 3. And anytime you square root both sides to solve, you need plus or minus. So here's our 2 answers. U is 2. V is plus or minus root 3. All right, let's check out number 6. I don't see any scalars, and it just says solve for z. So I see a z in the first row, but if I add that with 3y, I'm going to have 2 variables. That's not going to get me anywhere. Let's check out this row. -6 plus 3z equals 51. That's the row to use because I only have 1 variable. All right, so 3 into 57. Let's see if that divides evenly. 19. All right, 15 is not a solving, it's just simplify. It looks like we have a scalar of 4c. So 4c times 0, 4c times 6, 4c times 0. Let me make this big enough again. And then 4c times 3a is 12ca. You could write ac, it's the same thing. All right, 16. -3y times -2x is 6xy. I'm going to put my variables in alphabetical order. -3 times -1, y times y, -3 times -4, and then y squared. And then -3 makes 9, xy. All right, let's look at 21 for some order of operations here. We've got a scalar on the first matrix. All right, so when we subtract 30 minus 1, 5 minus 6, 10 minus -6, -30 minus 6. All right, and then on 22, I see parentheses, so I'm going to add the matrices first. 0 plus 2, -2 plus 0, 5 plus 2, and then do the scalar. And that's our result. Okay, so your job for the rest of class and due in our next class is page 10 to 11, 1 to 13, and 17 to 25 all.